Welcome to the lectures on problem solving and programming in C. This is lecture 17 and the title of the lecture is base conversion. In this lecture, we will discuss or develop algorithms or computer programs to convert numbers from one base to another. How to convert a number from decimal to binary and how to convert a number from the binary to decimal and so on. And we will generalize this. We will generalize to how to convert any number system to base 10 and base 10 to any number system. So first we have three versions here. How to convert a decimal to binary, and then next problem will be how to convert binary to decimal. And then we will generalize and ask how to convert from one number system to another number system. Let us go on. So how to convert? So we are talking about decimal to binary. To binary. For example, like we know the process, right? How do we convert a decimal to number? Suppose if you want 67 in decimal is how much in binary? Let us convert. So we will keep dividing 67 by 2. And then we will now note down the quotient and the remainder. And again 2. This will be 16, 1. And again 2. This will be 8, 0. And again 2. This will be 4, 0. And then again 2, 2, 0. And then again 2, 1, 0. And again 2, 0, 1. So we write down like this. We wrote down like this. So the number will be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, double. This is the number. If you observe this, what is the position? We want to see this as a integer number, okay? Integer number. We want to suppose 67 is given as input. Then we want to binary is basically we have to display the integer number 1, 0, 0, 0, 0, 1. Binary also we are showing it in an integer, but the form, the number will be actually contains only zeros and ones. What is the position of the first bit in the final number, final first quotient, reminder, the final number? It has 10 to the 1. 10 to the 1. Second bit will have 10 to the 2. And so on. Right? So we keep on divide the number and get the modulus with 10 or with 2, and then take out the remainder. The remainder will be multiplied by 10 to the power some number. That number will be added, keep on adding. Okay. Right. So this we can write like this, no? This 1, 0, 0, 0, 0, 1, 1 is equal to 1 into, say this is 10 to the 0, this is 10 to the 1. 10 to the 1, 10 to the 0, plus 1 into 10 to the 1, plus 0 into 10 to the 2, plus 0 into 10 to the 3, plus 0 into 10 to the 4, plus 0 into 10 to the 5, plus 1 into 10 to the 6. 6, okay. Right. So what we need to do, let us try to develop the algorithm. So extract the, try to extract the remainder. How long you will keep on dividing the 2? As long as the number is greater than or equal to 0. Okay. Let us try to develop the algorithm. Okay, right. This is algorithm. Decimal to binary. Input a decimal number, an integer number, an integer number, then greater than 0, greater than equal to 0. Output an integer number uh, showing the binary representation of n. Begin. Okay, so then input n, we need to read the input n. If and they should do a input validation. If n is less than 0, then output invalid input, read input, and then stop the probe. And if this is input validation, and then so what is the we have this is n decimal number n, but we need to represent the binary number, no? So binary n, binary is equal to 0. Initial value of binary is 0 because we are keep on adding one digit by one digit, digit value by one, face value by face value, right? Place value by place value. So let us while and so what is the first binary number? So we are multiplying the bit with the 10 to the power, right? 10 to the power 0 initially. So initial power is equal to 1. 10 to the 0 is 1. So while 10 greater than 0 do bit is equal to n mod 2. N mod 2. You will get the bit value. So what is the binary value? Binary value will be binary is equal to binary plus bit value multiplied by power. 1 0 multiplied by 10 to the 1 like this, right? So the bit value is multiplied by 10 to the power, where 10 to the power is multiplied every time growing by 10. So that is why power equal to power star 10, right? Then we should do n equal to n by 2. This is basically integer division. Integer division. Integer division means we are not discarding the fractional value. Suppose if we have n by 2, we are going to take only 3 and y. So output bin end. Okay. So this is let's go back here once. What we are doing, we are extracting the modulus of modulus of a number when divided by 2, that is multiplied by power 10 to the 0 initially. The next will be multiplied by 10 to the 1 and so on. And so on. We do that as long as number becomes greater than 0. Number is greater than equal to 0. Right? By the time you get 0, you already have the number in binary form. Let us try to convert this to a C program. A decimal to binary. Binary.c, right? So what I will do is I will hash include stdio.h int main, the empty program. I will type the empty program and a optional return 0. This is my empty program, and then there is input n. First statement is input n. Input n is basically, how do you convert input n? Int n, printf, enter a positive integer number n greater than equal to 0, right? Then scanf %d ampersand n. This is my equivalent C statement for input n. After that, I have input validation. If n is less than 0, then printf invalid input, stop is return 0. Otherwise, what we are doing, we have two variables, bin and power. So int bin binary equal to 0, int power equal to 1. Then we have this while loop. While n greater than 0. While n greater than 0, b equal to int b. Int b is not declared so far. Int b equal to n mod 2. Mod is basically percentage symbol. Mod 2. Bin equal to bin plus b star power. Then power equal to power star 10. Then n equal to n by 2. Okay, that's it. After this end value, we are just printing printf. I can do a meaningful message like this. Binary equivalent of decimal number, or else we can do something like this: %d base 10 is equal to %d base 2, comma n1 comma bin. Because we have modified n value, so let us take a copy of n here as in the form of n1. Int n1 equal to n, because I want that to appear in the output. Bin. Let us run this. ACC decimal to binary a.out. Let me give 67. You see here 4 zeros double 1. You see the number here, what is happening? 1 double 0 double 0 double 1. 1 double 0 double 0 double 1 is in base. This is indicating that this is base 2. This is base 10. Okay, right. Let us give some other number, 100. So you can verify this is the binary representation of 100. Right. Let us move on to the next number. So suppose the same algorithm, if I ask you to convert decimal to octal, what will be the change? Change will be, instead of here, change will be here, you'll have 8. These two numbers will be replaced by 8. Then automatically the conversion will be from decimal to octal, right? If you are doing base 5, decimal to base 5, it will be 5, base 5, right? Let us move on to the next problem. Next problem is conversion from binary to decimal. How do you take binary to decimal? For example, let's take the same number, 1000011 in base 2 is equal to 67 in base 10, right? How do you get 67? So we write like this: 1 0 0 0 0 1 1. So this will be 1 multiplied by 1 2 4 8 16 32 64. So it will be 64 plus 0 0 0 0 plus 2 plus 1 will be 67. So what you are doing is you are extracting the rightmost. We know how to extract the rightmost digit, right? That will be multiplied with 1. The next bit will be multiplied by 2. So it means that bit extracted multiplied by power, where power value is power default power first value is 1, and next for each iteration power is multiplied by power star 2. That is the logic. Okay. Let us try to develop the algorithm for this. Let me copy this. So many things will be similar. Right. So this will be decimal, binary to decimal. I remove this. Yes. This will be binary to decimal. Decimal. Integer number, integer number showing the so showing the decimal equivalent of decimal of n. So in binary. Okay. Let us develop. This is very similar to this. Input validation will be same. So what you will have? You will have decimal equal to 0 and power equal to 1, while n greater than 0 do bit is equal to n mod 10 you get the first bit, and then decimal equal to decimal plus bit value multiplied by power, and then power equal to power multiplied by 2, and then n equal to n by 10, and while output decimal end. Okay. Okay, let us try to convert this to a C program. So as many things are common, let us copy this binary to decimal dot C. A binary to decimal dot C. Okay. So it will be very similar. Power equal to 1, ny equal to 1, n greater than. It should be decimal. Decimal equal to 1, right? Decimal equal to 1. This is decimal. Decimal. Power is actually multiplied by 2. Then this is divided by 10. And then here 2 is equal to 10. Let us convert it. Let us run it. There is an error, bin. Okay. So there is no variable called bin, so it should be decimal. Decimal. Let us compile it. So let us take same number 1 00 00 11. So 67. is equivalent to 67, right? Like this, we can convert numbers from this. Now, suppose if I want to convert octal to decimal, what will change? Octal to decimal, what will change? Only thing will be this. This. Here instead of 2, I will multiply it by 8. I will multiply it by 8. Right? Of course, what we need to do is we need to validate. Here also we need to validate. What if the B value is somewhere here? We should have a validation, input validation. Input validation. Suppose here, if B is greater than 1, then greater than equal to 2. Let's say greater than equal to 2. Then output invalid input. Because if you are expecting a binary number will contain only bits 0 and 1. Since you are reading from the user, what if he enters something beyond zeros and ones? Okay, if he includes some digits bigger than 0 and 1, in that case we should say invalid input, and then stop the program. Okay, and if this should be here, this portion should be here. Okay. Earlier programs, so no such validation is required because the number is decimal, so it will automatically user will cannot enter anything. Digits means only zeros and ones, right? Zeros and 9, 0 to 9. So there is no chance of entering a invalid input. But here there is a chance of entering invalid. Suppose you are trying to convert the same octal to decimal. What will change is this will change to 8, and then this will change to 8. Only that is a change, right? Let us look at the problem conversion from one number system to another number. Okay. Since we are talking about integers only, we are storing the original number as an integer, and then the converted number is also an integer. So we cannot handle numbers in other than more than base 10. Okay, I can convert from decimal to binary, binary to decimal. I can convert from octal to decimal, decimal to octal, or I can convert from base 5 to base 10 decimal, or decimal to base 5, like this. So in that case, what we can do is, if there is a number is given, what we can do, we can convert it to decimal first. Okay, and then from decimal, suppose if base A to base B, if you want to convert from a number base A to base B, where A is 2 less than or equal to A, comma B less than or equal to 10. Okay, the A and B are base source and destination bases is basically 2 and 10. Because if for example, if hexadecimal, we need alphabets to represent each character. Okay, we need characters to represent some digits because we need more than 10 symbols. That is why those kind of representation we will see when we have more flexibility of storing characters, how to use characters also. Okay, storing the digits in the form of an array. So those concepts will come while discussing arrays or lists. Okay. So for the time being, we are only talking about converting from one base to another, where base A and base B are within 2 and 10. Okay. So suppose what I can do, I can convert base A to base 10. Base A to base 10. Okay. Then base 10 to base B. Base 10 to base B. This first I run the first algorithm, and then I run the second algorithm, and then I'll run the first algorithm, followed by first algorithm. Okay, like this we can convert from any base to any other base. Logic is same. So the existing algorithm can be used. Whatever the algorithm have written, only changes here base A and base B comes. Okay. So suppose if you want to convert number from decimal to base A, what happens? Here base A comes here, A. Okay. Then base A to base B, decimal to base B. So decimal to base B. This is decimal to base. Base A to decimal. Base A to decimal means here A will come. A will come. Okay. then you have that particular number in decimal. Then decimal to base b. Base b here instead of 2, you'll have b. Okay. You need to combine these two algorithms to form the corresponding thing. For example, what I mean to say is, suppose if we know that 67, right? So 1 0 0 0 0 1 1 in base 2 is equal to how much in base 8? Suppose if you are asking base 8, okay? What I can do is I can convert it to decimal. What is the decimal equivalent? Decimal equivalent of this is 67, okay? Then how do you convert it to base 8? Base 8 is basically by dividing 67 division 8. Sorry, this is 67. So it goes 8 times. 3 is the thing. 8 1 0 8 0 1. So 103. 103 is the octal number. So like this. So here a equal to 2. My input number will be input. What are the input? N equal to 100 0011. And then my a equal to 2 and b equal to 8. It means that 100 100 is in binary representation, and we need to convert it to octal. So what I did, using the second algorithm, I converted to decimal, and using the first algorithm, I converted to octal. Like this, we can convert from any number to any number system to any other number. Thank you.